Okay, everyone, hello and welcome back. I apologize for the delay. We had some technical issues with GoToMeeting, but we're good to go now, I believe. So I'd like to welcome you all to this IBWave Asia Pacific 5G webinar. My name is Damien Damasio, Senior Director of IBWave in Asia Pacific. With me today, I have Kim Tai Kwa, who is our Senior Sales and Solutions Engineer supporting us in the Asia Pacific region. I thank him for being my co-presenter today, and all of you for your time today. Today's an exciting session. We will discuss how IBWave can help you with your 4G to 5G evolution in building and even out of building. So welcome all, and I hope you enjoy the session. Before we go into the details, I just wanted to have a quick rundown of housekeeping for the webinar. So the webinar is currently being recorded. What we'll do is we have everyone's registered email address that came to the session. We will package that up and send it to you by email in a few days. So you will have a recording that you can play back and skip forward to any sections that are of interest. Also, if you have any questions during the session, feel free to open the question box. We've got a few of our staff here to support, so we're happy to take any questions during the webinar at any time. Just feel free to text us. If we cannot manage during the webinar itself, we'll have a record of the questions and we'll get back to you as soon as possible. All right, so today we're going to try and run the webinar within about 45 minutes. So we're going to cover a few topics. The first is the key features of 5G compared to LTE. So a very brief technical overview of the updates of 5G. And of course, each of these updates are relevant to IBWave. So whatever features are in 5G that we cover today, you can control them and set them accordingly in IBWave and have an effect on your design and see the difference to 4G. The next section, I'll be handing over to KT, and he'll be showing the best practices when it comes to 5G in-building design using IBWave and also campus as well. So indoor and outdoor for small, dense areas can also be done. And we have all the 5G settings that you can use for your specific needs. We'll have an IBWave 5G demo. So IBWave has supported 5G for a couple of years now. So we have all the parameters there, and KT will run through a brief on how to set some parameters and the effect it has on your design. And then we'll wrap up. There'll be a special offer at the end. If you stick around, you'll see quite a good offer when it comes to 5G. And any questions and answers we can cover then as well. And of course, we'll close up and then send you the recording afterwards. Okay, so what I'll ask my team to do is, if there are any questions, just keep an eye on the chat box and feel free to answer them during the session. Okay, so let's begin. Before we go into 5G specifically, I'm not sure how many of you are currently using IBWave or haven't used it for a few months or a couple of years or are brand new to IBWave, but there has been a lot of changes over the last year, and this slide tries to capture those updates. So the first one in the top left is the indoor-outdoor capability. You can see that previously IBWave was focused purely on in-building, but we recognize that the network is one network, so the macro network does impact the in-building, and vice versa, the in-building system can leak outside. So we have a solution now that can enable you to visualize the macro network coming into the building and the in-building network leaking outside the building. And that's really handy for campus designs if you have, say, universities, hospitals, business campuses where you want to cover the region inside and outside. So that's a product called Reach, and we highly encourage you to contact us to give you a demo of what that looks like. It's really cool. Personally, I have wanted this for a long time, and it's something very nice to see as an engineer. The next part, the top right here, is the multi-technology mix that IBWave covers. So previously we were focused mainly on cellular, but these days we do all network technologies, including Wi-Fi, private networks, emergency systems, and even wire lines. So we even cover fiber into the building and so on. So just think of IBWave no longer as a 3G, 4G tool, but it's an all-in-one network design tool, and also with Survey, a network measurement tool that's CAD-based, so it's very highly accurate. Going down to the bottom left, we have the database of components. Now, every year this goes up by a few thousand. IBWave has the largest database of components in the world, 37,000 at the moment. And these are all different kinds of components you need to build up your network. You can see the picture there on everything from amplifiers through cables, connectors, up to antennas. So everything you need, drag and drop, the specs are there, and you can take what you need depending on your preferences of equipment that you select. Finally, we have a large ecosystem of partners. Apart from having over 1,000 customers around the world, we have a number of OEM partners to gather those specifications of the equipment, and also tech partners, system integrators, many of you who are on the call today. We have a very good partnership with everybody. So everybody knows us, we know everybody. So whenever anything needs to get done, it's a nice community that we have together. So you're all welcome and part of it, and any contributions help everybody else. So it's a great thing to see. Okay, so going on to the next slide. We go into the 5G feature set now. So there'll be 4 slides covering the key features of 5G as opposed to 4G. And then I'll hand to KT to explain how to set these parameters in IBWave. So the first one is the 5G frequency bands. So these are new bands that have been defined for the purposes of 5G. They didn't exist before. And they're mainly grouped into 2 designations by 3GPP. The first one is the sub-6 gig band. So most of the bands already defined by 3GPP that fall within this range can be used with 5G. So it's ultra flexible. It can be the GSM, LTE, and any other bands that they've defined within this lower frequency range. The main purpose of FR1 is for citywide coverage, lower frequency, longer range. So that's the purpose of 5G, to do the footprint. And then the specific need for the FR2, which is the millimeter wave high frequency bands above 24 gig, is for the very dense small areas. So some cases that I've mentioned below in the slide: stadiums, convention centers, hotspot areas. So you've got your high capacity zones and then your citywide coverage, so you have seamless customer experience. So both of these are required to make 5G work, and particularly FR2 is where you'll get the real-time applications and the very high throughput demand applications working in 5G. The next main feature is what we call numerology, and numerology is defined as the sub-carrier spacing and slot duration. It's quite technical, but basically it's telling you the latency specifications for the particular service. Now in LTE, there is only one numerology or duration that is defined, and 5G has improved that by defining a number of different ones. You can see in the table below, the numerology on the left defines different subcarrier spacing and TTI intervals. And that basically allows you to select or define your network or your slice for certain applications. So it enables you to control your RF latency. Of course, latency is RF plus the wired, the internet side, the core side, but the RF side can be controlled using numerology. So we'll see later how numerology can impact the RF latency of your design. And that depends again on your applications that you want to use on your 5G network. So more flexibility for certain applications. The next one is known as network slicing. So again, 5G is being promoted as the ultra flexible technology. It's not purely for high throughput, high capacity. It can be for mobile broadband, which is what 4G is mainly aimed for, but it can also be for things like IoT and real-time, either autonomous driving or remote applications, whatever it can be. The idea is that network slicing allows you to split your network into different slices or segments and then have different parameters on those slices so that they are optimized for the services or the applications that you want to deliver. So the diagram describes an example where, depending on the application, which can be, as you can see on the right side, maybe just for communications, then you would define a mobile broadband slice where maybe latency is not as high a requirement, but throughput is. But then if you have something that's real time, like the third box down the bottom, an automotive or medical or infrastructure like a factory with robotics where real time control is mandatory, then you would have a different kind of slice defined. So you'd have like a mission critical slice, which would have ultra low latency definition. So you can, and this can be all done in IBWave. You can define network slices and you can set the slices accordingly. So you can ensure that particular parts of the building or the entire building is serviced by that slice at the KPIs that you need them. And the final feature that I'd like to cover today is known as beamforming. So this is where it's not particular for 5G, but it's being heavily used in 5G, and it's required in 5G for this purpose. So in 5G, the GNode B can have multiple narrow beams. You can see in the diagram below a visualization, which you can see in IBWave actually, a 3D visualization of what these narrow beams look like. And the idea of the beamforming is that you can optimize particular beams for particular users or parts of the cell. So whether it's the data channel, which is on the left, where you have many beams, or whether it's the synchronization channels for your SINR control on the right, we're basically able to say that there's no longer a single beam where maybe the throughput is not optimal. Each user, in theory, should have the best RF conditions because of beamforming. So in IBWave, KT will show you how you can define the beamforming based on the antenna manufacturer you select. And as a result, you will see an overall better throughput, not only by customer, but by cell. So you get the most out of your network by using beamforming antennas and technology. Okay, so I see that there's some questions coming through. That's excellent. I will try and get to them. If not, I'll ask my team to respond, but thank you, keep the questions coming. What I'm going to do now is I'm going to hand over to KT, and he will run through the best design practices that IBWave has seen around the world after 2 years of implementing 5G. We're happy to share those with you by separate discussion as well. We've learned a lot about certain parameters and how to set up IBWave to visualize 5G compared to 4G. So we're happy to help you along the journey of 5G. So let me hand over to KT and he can continue. One moment.
Okay, good afternoon, everyone. My name is KT. I'm Senior Solution Engineer from IBWave and currently I'm based in Malaysia. Now I'm going to share a few suggestions of 5G NR design best practice with you. We know that SSSINR, which is signal to interference noise ratio, or PDS-CH SINR, which is important if you want to calculate what is your maximum achievable data rate. Then you need the beamforming antenna and have such individual beam defined. So what I'm now showing you here is our tool, IBWave Design. The user can have their individual beams defined, whether it's SSB or PDS-CH. So for example, at the left bottoms picture, you can see that there's number 11 here, and it says this is the beam SSB. It means that in this individual beam, is defined as a beam ID number 11 and serve as a SS beam. You'll also see that this individual beam is defined in a certain directions, in horizontal cut and elevation in vertical. So on the right bottom pictures is the same thing, but this is for the PDS-CH. This is defined as a beam number 4, is defined as a PDS-CH beam. So this is our feature that how IBWave user can define the SSB and the PDS-CH beam based on their technical data sheet and simulate the valid SS-RSRP and also the PDS-CH SINR heat maps. So as for the best practice in the design, we are suggesting that to check if both beam pattern and the individual beams are defined properly in IBWave design. So when you have a small cell which is 5G enabled, you can double click on the part and then there's an option to view the antenna patterns. So when I click on that, then there's another window. It's going on to open, and then you should click on the beam type. You should see both beam forming pattern and individual beam. And if you don't see the individual beam number, then it means that only beam forming pattern is present. And that means only SS-RSRP is going to be available for your heat map calculation. Although you still can do SS-SINR and PDS-CH SINR simulation, but those calculations are not going to be valid. So you need to do your sanity check to double click on each part and go to view on antenna patterns. So the second best practice is to take a look at what is defined as UE beam forming antenna gain. So far we talked about the beam forming. We only talk about the beam forming at the base station or the G node B. So what about the UE? Does UE have the beam forming? The answer is yes. It does at a millimeter wave frequency. For the teardown report on iPhone and what Samsung has said in some public presentation, they have two RF modules at millimeter wave frequency. Each of these modules is 4 antenna array. So why do they have two modules? It's because each of those two modules has a different linear polarization. One is plus 45 degree and the other one is minus 45 degree. And then with the 6 dB antenna gain. So our suggestion is to define the 6 dBi antenna gain in our tools. The next topic is on the body loss. The body loss is higher at millimeter wave compared than at sub-6 GHz. In IBWave, we measure body loss with 2% penetration to be in the 20 to 25 dB range. If a stadium antenna is mount overhead, we think that 1% penetration is 15 dB. Body loss is going to be more appropriate compared to the 20 to 25 dB. This is the body loss suggestion based on the worst case scenario that if the stadium is full house and everyone is standing up during the game or during the concert. Third, we come to decide where is the antenna locations. You do not want to have anything metal in near field, and because that will severely affect your antenna radiation patterns. Do not install your antenna like this shown in the figures. Oops. Sorry, the screen not move. Come again. So you do not want anything near the anything metal in the near field, and because that will severely affect your antenna radiation pattern. So do not install your antenna like this shown in the figures here. These are the bad example where you have a lot of metal in near field of your antenna pattern. And this is our suggestion of the antenna exclusion zone number 1. So now we come to exclusion zone number 2. is for EMF radiation compliant. In the small cell design example below, which has a combined ERP of 60 dB, which is considered very high transmit power. We need to calculate what our radiation compliant distance is when all networks are active. Given that there are multiple technology deployed at the same venue like 3G, 4G, 5G, or even Wi-Fi. We need to be aware that the millimeter wave will be a significant contributor because of its large ERP. For the compliant distance, we can figure out location of the exclusion zone number 2. Now we know that what is our exposure zone number 1 or number 2. So we need to basically figure out which one is larger. Then during the site survey, we try to find the location in the venue where we can have the clearance between our antenna and the larger of these 2 exclusion zones. So for millimeter wave propagation, I can tell you that we've seen that there are 2 types of material. As far as propagation at the millimeter wave, they are heavy and dense materials such as concrete and bricks. They will not let the millimeter wave signal through, but they also have a light indoor material like sheetrock that may let the signal through. It depends on a few factors like how many walls in between the transmitter and the receiver, and so forth and so on. So we also seen that some flat indoor objects would like to reflect the millimeter wave signal very well, such as the whiteboard or the large flat TV screen or the large mirror. So to the best practice, we would like to suggest to design indoor millimeter wave network as strict as in the line of sight. So we need to choose the venue with a high user density and with a good line of sight, such as the conference room, cafeteria, stadium, and the conference center for the millimeter wave network. And don't forget to model the highly reflected object if they are larger than 1 meters. Next, I will move on to the demo for an example of the design. So first, what do we have here? So we have this floor plan with a partition defined. So with a design of small cell, and these are their locations. So let me show you how they look in 3D. So you can see the partition is defined. And here are our transmitted antennas. So these are the antenna located at the cubicle area, and these are the antenna covering the meeting room, and these are antenna covering the entrance. So from the entrance, this is the hallway lead to the meeting rooms. So all this analytic on the floor plan. What we like to do this? By doing this, we can strategically focus on the area where we expect a lot of UEs. We expect a very important user in an area which is cubicle. We also expect the highest number of users right here. And all these separation wall for the cubicle are not very high. So we have a very good line of sight here. So we also have this area in the meeting room and the reception desk. So where we want to put our antenna? So we can imagine when the guests are coming to the office, they arrive at the entrance, and then they are always invited to the meeting room. So we must make sure that we need to provide a very good connection with a high throughput from the entrance to the meeting room. So beside that, we also need to make sure that there's a continuous connectivity from the entrance to the meeting room. and make sure the hallway is covered as well. So this is how we strategically decide where are the small cell locations. So now we need to go to the property to make sure that what we did on what we decided before. So in IBWave design, when we go to do our sanity check on the parameter configurations, so you can go to the property. So for 5Gs, you can go to the 5G NR technology here. So this is what we mentioned previously by Damien about the network slicing. So in IBWave, we call this is a bandwidth part. So usually nowadays, for example, in 3.5 gigahertz, that we have 100 megahertz bandwidth. And then this is a starting of the deployment of 5G project or the network. So the 5G user may not be high. So the operator may not want to fully deploy the 100 megahertz bandwidth for 5Gs. So what they can do here is they maybe separate it, 80 megahertz bandwidth for 5G, and then the other 20 megahertz they can define as, for example, IoT. So in our tools, we need to define this IoT here as a bandwidth part, and later on we can use this profile in our system configurations. So come to below, we have this EMS setting. So these are the safety distance setting that customer can set based on their country regulation. So by setting this, after setting this, our tools will calculate the safety distance between the human body to the to the antennas. So by doing this, we can identify where is our exclusion zone number 2. So let's move down to the MIMO. So in our tools, we do have this 5G and MIMO's gain chart defined. So all this value is based on the 3GPP. So it's already predefined. So in here you can see the setting will be 2x2 MIMO, 3x3 MIMO, or 4x4 MIMO that we can support. So next we'll go to the network optimizations. So in here you can see various type of technology IBWave covers. So in 5G NRs, so you can see here there's an antenna gain. So during the previous recommendation, we recommend to define the antenna gain as 6 dBi and the body loss 15 dB. So this is a sanity check that we need to do. So let me enlarge this screen. So at the bottom, you also can see that in our tool, we support 5G NR up to 256 QAM. So all these parameters are set based on the 3GPP standards. So after we do this sanity check, so we go back to our floor plan. So now we need to check our signal source. We double click on this small cell. So in this small cell, you will see that what is the manufacturer name, what are the models. So this is the small cell which cover 2.1 gigahertz LTE, 28 gigahertz millimeter wave, and 39 gigahertz millimeter wave. So it have the SSB beam defined, PDSCH beam defined, and also the PUSCH beam defined. So the transmit power will be 20 dBm. So this value is based on the manufacturer's technical spec. So at the bottom, you also can see the antenna patterns. So in 2D and 3D. So this small cell is defined as a 2x2 MIMO. So we can click inside there. So in here, we need to make sure that we define the band properly. So in here you can see we support up to 60 gigahertz millimeter wave and 3.5 gigahertz for 5G NRs. So LTE for 700 megahertz. So let's see for the 5Gs. So we go to the millimeter wave. So the millimeter wave for the 5G network is actually a little bit different from the LTE. So in 5G, you'll see that there's a slightly different additional configurations are required. So at the bottom, you can see this sub-carrier spacing, which is a terminology that we mentioned previously by Damien. So these are the 5G's features and the resource block along with the sub-carrier spacing configurations. We also have another flexibility on 5G, which is the slot allocation. So what is this actually do is this will affect the capacity calculation. So in 5G nowadays, we have this more flexibility, like for example, in those stadium venue, which the user behavior nowadays tend to watch the concert or the football match. So they tend to record it down and share it in their social medias. So the uplink traffic will be more. So the requirement will be more. So in such a venue, we actually can reallocate the slot allocation between downlink and uplink. So to make the uplink having a more resource. Okay. So final one will be the bandwidth path profile. So these are the one that we mentioned. Once we already define the another slice or the segment, for example, IoT, then we can select here and then we just allocate 20 megahertz for this IoT. Okay, so now we make sure that we have configures our single source properly. Then we go back to the floor plan. So the next thing we need to check is the wall material. So we double click on the line. So you will see that this is the dry wall that defined here, and then these are the wall losses per frequency band. So it support up to 60 gigahertz. Okay. So next we will move to this beam configurations. So do we define the beam properly for SSB and PDSCH? So in IBWave, we have a database editors where you can check or define your own components. So in this example just now, the small cell 2.1 LTE, 28 gigahertz and 39 gigahertz millimeter wave. So in here you will see the manufacturer name, the model's name, and the description. Okay, so the wireless that they can support, the 5G NR and 2x2 MIMO. So about the beam, we can go to the band. So you can see that can support 39 gigahertz. So in 39 gigahertz, we see there's a multi-beam was defined. We go to beam 1. So you see that beam 1, the ID, SSB ID defined as 1, and then is defined as the SSB beam only. So these are the antenna patterns for this beam, beam number 1 for SSB beam. So whereas we can go to, let's say, beam 7. So beam number 7, we do define this as a SSB beam, PDSCH beam, PUSCH beam, and also the CSI beam. And then below is the antenna patterns for beam number 7. So we make sure that we define the beam properly. So now we are good to go. Go back to our project. So here we create our prediction plot. So here we can create a prediction plot for 5G NR, the SSRSRP, SSSNIR, the PDSCH SNIR, and capacity, the throughput, the downlink throughput, uplink throughput. So let's see what is the coverage here. So we can check where's the coverage, SSRSRP. So see, we only strategically cover some certain area. So we need to see that, okay, the area like this, cubicles here, we achieve our coverage. So SIM is pretty good. And then from the entrance along to the hallway, all the way go to the meeting room, we have very good coverage. So as you can see as well, when the signal pass through the wall, the signals, the millimeter wave signals is become very weak. Yeah, so that's why we suggest that to design the millimeter wave in the best or better line of sight environments. Now we also can go to see the others plot. So for example, PDSCH SNIR. So here you can see the SNIR and the downlink throughput. Let me zoom in a little bit. You can see the purple color is about 3.7 gig Gbps for the millimeter wave. So in our latest 16.2, we add in this uplink throughput as well, the maximum achievable data rate. So now our user now able to simulate what is the uplink throughput for their millimeter wave. So in our tools, what is another thing, since we talk about the beamforming, so can we simulate the beamforming? Yeah, yes. So we do have this 5G NR best serving beam simulation. So we click on this. So you'll see these circle things here. This circle thing means we simulate an UE in this location. And this UE is served by the best force beam in this area. So from the legend, we can see that the green color is from the AP18 served by the beam number 26. So it's serving by this small cell here. So the number 2 best beam will AP15, and then the beam serving is beam 25. So in report, we also can generate this best beam report analytic, best beam analytic report. So you'll pop out another report like this. So we show you the flaw. And then also you tell you that, okay, the best number 1 is AP18, and then the beam serving is 26. Then the second best beam is AP15, the beam 25. Okay. So last, what I want to share is our capacity. So in our tools, we are able to calculate the capacity for 5G. So what the user need to do is, again, they go back to the properties. So under the capacity, we need to define how many user in this flow. For example, we have 50 user in this flow, and what are the usage profile? What is the user behavior is a conference, HD video conference. So how we define the profile is, need to go down to here, capacity definition, the usage profile. So in here, these are the example just now, HD video conference. Let us double click and see what's inside. So we assume that this is for the meeting purpose. So these are for the video conference. So the meeting time duration is 1 hour. So during this 1 hour, what the user do? So since this is maybe the stream meeting or Zoom meeting, so they need to have a stream high definition video for the whole 60 minutes this hour. So maybe the user will also need to make some phone call, for example, 5 minutes, and then they need to search for some information via the web browser. So this basically define what are the behavior will happen in that situation or the user behavior. So when we have this kind of user behavior defined, so it will convert to the file size need to be transmit. So it will come up with this total file size to be the transmit, and then what are the throughput required per user to handle this file size. So 24.71 the user. So with this setting, and then we run the capacity, then our tools will basically inform that this is passed or not passed the capacity definitions. So you also can activate the probes and move the mouse cursor onto the floor plan. Then you will see the more details elaboration. So the target throughput will be 24.71, and then based on our calculation, the average data rate per client at the cell load of 50%, they can achieve 136.33 megabit per second. So this end of the demo of the project. So let me move back to my presentation slide. So last, let me summarize again what are the 5G's design best practice are. So number 1, we need to check the GNOB antenna pattern for individual beam. Are they defined properly? Secondly, we need to adjust the UE gain to account for the UE beamforming, which is 6 to 7 dBi. And we need to set the body loss as 15 dB. So we make sure that the ERP per path is in the spec range. In order to configure those parameters, you need to have access to the manufacturer's technical spec sheet. And you have to have the access on how it is modeled in IBWave design software. So we need to always determine the antenna exclusion zone number 1 and number 2 before the site visit. So during the site visit, we first need to identify the potential antenna location with the building manager based on those exclusion zones. So only after those locations are determined, we run the prediction and finalize the coverage scope with the building managers. So we do not want to promise the building manager that he or she will have the coverage in the area where they cannot possibly be due to the restriction of the antenna location. And those restrictions are imposed because of the exclusion zone number 1 and number 2. And we also need to make sure we only use line of sight design for the targeted coverage area for the millimeter wave network. And don't forget to model highly reflective objects if they are larger than 1 meter. So that is the end of my demo, and I'm going to turn over to my colleague, Damien, to complete the presentation. Thank you.
Thanks, KT. If you could actually keep sharing your screen, KT, there's only 2 slides left, so we'll leave it with you. So thank you, KT. I hope that was really informative for everybody. A bit of hands-on, nothing as good as seeing the product in action. But I do appreciate there's a lot of information in this webinar, so feel free to play it back at your own leisure. And we also allow you or offer you the ability to share a half a day to a day with IBWave for us to do hands-on, or for you to be able to learn the product for the 5G purpose. So we will have a special offer at the end for people who would want to spend a bit more time learning how to design 5G networks using IBWave. But just before we go to that slide, this slide basically covers how to make your IBWave 5G ready. So for those customers that already have IBWave and have been using it for 4G or for Wi-Fi or fiber or any other purposes, in order to make IBWave 5G capable, there are two things that need to be satisfied. The first one is that the annual maintenance and support is active, which means that every year you pay a fee to get the latest updates and to get support from IBWave. That needs to be active because the 5G features are embedded in the AMS. They're not a separate module as they would be with other products. So the AMS needs to be up to date and on. So with that, you'll receive all the latest 5G features. An example is one that was released in August, which includes 5G uplink. And uplink is just as important as downlink in today's world. And a couple of features coming, just for your information, and another reason to have AMS is that 5G carrier aggregation will be released very, very soon, which is very handy for those who are aggregating different frequencies, whether it's sub-6 or millimeter wave. And the other major feature that's coming very soon is 5G for survey, which means you can do 5G measurements and then import them into IBWave for better, accurate predictions. So it's always good to have your AMS up to date. The second one is ensuring that you have the right modules within your IBWave license. So there is an IBWave base license, and then you've got a couple of modules called propagation, optimization, and collection. You've got 3 additional modules. Now you need to have propagation and optimization modules in order to activate 5G, because 5G is mainly predictions and mainly optimization parameters. So those need to be included in your package if you don't have it already. Now, if you're not sure about either of these, no problem. Just contact your sales manager or sales@ibwave.com, and we will just verify to make sure your license is active and it has the right modules. We can answer that question quite easily. Okay, the second one is 2 recommendations I wanted to include in this webinar. The first one is both to try out some new products that maybe you haven't done before. So we have a product called Survey, and this is a hand phone or a mobile-based Android app where you can go to site and you can do the complete survey of 4G, 5G, which is coming soon, and Wi-Fi. And you can go there, take photos, do initial surveys, even make some basic designs, go back to the office, and once the in-building system is updated to include 5G, you can then go back and do measurements. So imagine it being like a TEMS or a NEMO, but a lighter version, but it's all within the one product, and it's very affordable. So something I encourage you to try. We can send you a trial license and give you a demo, but it's very easy to use and it covers all the technologies. So something that can complete your in-building experience. The second one I mentioned earlier in the webinar, which is called Reach. And I encourage you to try this out because, again, it's important to know what the macro network is doing into the building in order to make sure that your indoor system has dominance within the building. And it's also important to know if the antennas you're choosing or the placement of the antennas are affecting the outside network. So this product Reach can help you to visualize this indoor and outdoor behavior. So again, it's something we'd love to demo to you. Just reach out to us and we're happy to show you both products. Okay, so the final slide for today, we have only a couple of minutes, KT, just to flip over. Thank you, mate. So special offer for today. As you can see, 5G is quite a step from 4G. There's quite some specific parameters that we need to use, and there's quite some big impact on the performance of the network based on these parameters. So we highly encourage you to take up our 5G NR training. It's a very short course, but it covers the 5G basics and it covers how to design the 5G network using IBWave. So out of that few hours that you spend with us, you'll be much more confident in designing for 5G. So for today, or not for today, but if you contact us as a result of the webinar, we'll give 25% off this course, and we can tell you the price and explain the agenda and the contents of the course. So if you're interested, we're more than happy to share our experience with you. So just contact the IBWave sales rep or sales@ibwave.com, and we will be happy to support you there. So you can see that this course has already been used by hundreds of our engineers, particularly in other regions in North America and Europe. Quite well received. It's very specific and it's short enough that it doesn't occupy a few days. So you can get the most out of this step, especially if you're an IBWave professional already. It's really just a top up for the 5G specific parts. So I think that's all for today. We have 2 minutes left before our hour is up. Again, I apologize for the earlier issue, and I do realize my team's window was up there a bit too late, so I'm sorry if it covered the slides. We can share the slides as well as the recording with you. Just email us if you need the particular slides, and we're happy to help at any time. Keep giving us feedback about the IBWave product. We always are developing it to try to help out our engineers. We have 3,000 or 4,000 engineers using the product, so we always want to improve it. And keep in touch, because we always have exciting new releases, 5G and related to other technologies, every 3 to 6 months. So thank you again. A big thank you to KT for going through the technical aspects in the demo. And I'm looking forward to meeting you all again once travel is up again. But in the meantime, please stay safe and take care and keep in touch. Thanks for your attendance. Take care. Bye-bye.